Okay, so now we are doing this problem. This is minimum cost to split an array. It was also in yesterday's Leetcode contest, question number 4, and the date was 22/1/23. And today, let's do this. You have been given a number array, nums, and integer k, and then you need to, form a you need to split this array into some subarrays, and you want to return the minimum possible cost of splitting this array. Like how many splits you want to do, that's not given. You can do as many splits as you want. And then there is an importance value of each subarray that you are forming. So basically the final cost, how this cost is coming, this cost is the sum of the importance value of each subarray. Now what is the importance value of each subarray? Importance value of subarray is k plus trimmed length. What is this trimmed length? Trimmed length is basically when you have a subarray, you need to form this kind of subarray where all the elements which are unique can be removed, and you need to take only duplicate elements into consideration. 3 3 4 4, then length is 4. That's why the importance value would be k plus 4, and total cost would be this summation of that importance value. Now for example, this, let me tell you, there are multiple ways to split this, right? And yeah, so number of ways to split this would be looking like key. You can do like this one array and this second sub array, and then you can say like, yeah, then also basically this is a whole approach also. Key after this, you'll say key, this is my sub array and this is my second sub array, not second, but from this part there will be coming multiple sub arrays. So let's say I make a split over here, then I make a split over here. So this is the ways to split this array into four subarrays. Okay, now they have not defined the length, so you can either do five subarray, or you can either do six subarray, or you can either do seven subarray. That is the total length, basically, 1 2 3 4 5 6 7. So total number of subarrays that you can form is up to from 1 to length, like one, in which case one is this, you can see, yeah, this is complete, treating all as just one single array, don't split it. So that is also a possibility. So brute force way would be to go for each length, 1 2 3, and then calculate answer. But yeah, that would be very brute force. And I don't know, like what, how you will be calculating answer for one. When you say okay, for one it's simple. For example, let's say 3, you are saying that you will be splitting this array into 3 sub arrays. Okay, yeah, then you can do, you need to make to split it into 3 sub arrays, you need to make two splitting points. Okay, so how many splitting points are there? So n minus 1 total points and c2. Okay, this is basically n minus 1 c2 points you have to select, right? 1 minus 1 c2 points you have to select. Basically this is the way to choose 2 points about which you will be splitting. So then you choose 2 points, then you see the about those 2 points, how you'll choose 2 points. For choosing 2 points you need for loop of basically two for loops, right? For I and then for j. And then if this number is huge, let's say you are choosing n like, yeah, n minus 1, choosing 5 elements, five loops will not be, that would be very very brute force, very very time consuming. N is up to 10 to the power 3, which is less, but it's not that less that you can do like this way, nc2 kind of factorial way you cannot go. Yeah, so at max what we can go n square, even more than n square, but cannot go n cube, right? Less than n cube, that's thing. So we'll try to do this in n square. Now how to do this in n square? So the approach would be dp and recurrence, basically. Then you can optimize that recurrence with a dp. And recurrence means, what I mean is like just a basic recurrence, do whatever that is possible, every possibility you have to calculate, right? So this is the thing, and let's see how we will be calculating every possibility, right? So for example, now I'll be saying that, okay, I'm traversing on this arrow. Let's say I'm going from left point to right point. At any point, I can say that, okay, I don't want to take more elements. This is my one sub array, and those elements I will be dealing, like, I don't know how I'll be dealing with that, but I'll be dealing with that separately. Okay, so this is one sub array, and this would be giving me some sub arrays. I don't even know what the number of sub arrays it will give me, but yeah, that's about it. Then you call on this sub array. Now you'll say, okay, now I'm traversing from this index, let's say I, and then there is index like, let's say I'm traversing it. At any point I can decide, I have two options, right? At any point I have two options, like whether to make this as a new sub array and like do work for, let's call for the different remaining elements, right? Otherwise I can say okay, let's keep on moving, and yeah, take this also, and then let's say pause over here, and then calculate answer for this differently. You can separate at this point. So that's what you need to do. You will just traverse, and at every point you have option, every index you have option of split or continue. So ठीक है, the two boundary cases are when you do only continue, you will keep all the sub arrays into one split, and when you do split at each index, you will have all the n total number of length is equal to total number of sub arrays. Then, so that's what we will be doing. Let's do it quickly. Okay, so this is the whole approach, but There is a trick to it which we will realize after doing this. A small trick to it. How you'll be calculating out the cost for this hour. Let's say, oh, okay, arey yaar, what happened? What's happening, man? I don't know why is it happening. Yeah, what I was saying, how will you calculate the cost of this array? So you can split at any index. For example, you choose to split at this index, right? You choose to split after this first point. Then how will be calculating the cost of this? Let's say you choose to split at this point. How will you calculate the cost of this? Okay, so cost of this would be, you have to treat this complete subarray and then check the number of elements, check the duplicate elements. That would be very time consuming. Okay, that would be, I think, order of n again. So n square into n, that would go n cube, but we will not do that. So for that, okay, if I've explained, so let me explain the thing also. How you tackle that? You'll tackle that using pre-calculation, using some pre-computation for each sub-array. You will calculate its cost, okay? And then when you say, okay, I'm choosing this sub-array, you don't need to go iterate over this array and then see what's its cost. You just have this cost, right? So yeah, that is the thing. So first of all, and you'll see how it is helping us, how it's making the time complexity from n cube to n square. I think you might have guessed, but let's do. So I'm using a store which will give me some things of n comma vector of integer of n. Then I'll be saying for integer j is equal to j is less than. There are multiple ways to do this, right? So what I am doing, I'm just storing this. So basically, what you have to do, let's say one to one to this array I'm copying. Yeah, let's say this is the thing. Now let's say you are starting at this point. Okay, you will say key now store of you for example, you are on this subarray, okay? Then you will see the total number of counts of duplicate elements, that duplicate element. So in this subarray, that you will add that for that, and then you will use it in this. Can you use it in that? So I is listen. So I'm currently standing at I. I'm saying j is any index after this. J can be this, j can be this, j can be this. When j is this, I'll be calculating answer for this subarray part, right? So I will take all the elements up to j, and then I will say that I to j, what is its cost. So how I'll be doing that? I'll be doing that using map integer, comma integer. Okay. You can also create a frequency array. Okay. Now this is a new way to do this. And that would be why I'm taking it 1001, because maximally your number can go up to 10,000, and your range can go up to 10,000, right? Sorry, 1,000, right? No, your number can go up to 10,000, 1,000 also. Hmm. You can keep it anything, right? 1,000. Now what I'm saying, m of a of j plus plus, this has came over, this has came over, this has came over. So now you'll see its frequency if m of a of j is equal to just 1, okay? Which means this is first time it's coming. I don't need to do anything. Let's say is equal to 2, then I need to do c plus equal to 2. When like 1 and 1 comes one time, I don't need to do anything. 1 2, no, it's good. Like answer for this is 0, the trim length. But for 1 to 1, the trim length is 2, right? Directly from 0 to 2. How? When you see the frequencies of an element is 2, you can say just c plus 2. Else if m of a of j greater than 2 hota hai, to c plus plus, right? For example, when again 2 will come, you will do plus 2. But when again 1 will come, you will do plus 1, because one frequency is already greater than 2. Hmm. Now it's 3 now. So you'll say C++. Now that's all about this. And yeah, that's all about this. Store of from I to J would be just counter value. c equal to 0. Yeah, because all these elements will be, yeah, that's why you can, like, you can just think out and then create the store array. How you'll be dealing with this, moving window, like j is continuously moving, including more elements, more and more elements, and store of ij. You'll see this element if had been previously existed, so then its frequency 2 greater than 2. Based on that, you'll do store. Now storing is done. Okay, I think it should be fine. You'll just return your answer now. How to return your answer now? Basically, and I is equal to 0. There are two ways to do this. One is recurrence way, one is tabulation way. What do you want me to do? Maybe this would be, obviously recurrence is more understandable, so let's do that. And id equal to 0. From 0 index I'll be starting. You know this logic. Okay, now you know the store was the new part for you. I've already explained this next logic, which is pretty simple. Like, you will start from the 0 index, keep on traversing, choose any index, you will break at this, and you'll say that this is the subarray I'm taking, so this is the subarray, and then you start from the next index, and you'll say break at this point. Okay, you can break at any point, so you have to choose every possibility, right? Break at this point, send answer for this one, break at this point, send answer for this one, and then you need to return minimum. So yeah, and nums array will be passing. Okay, nums. Okay, I've taken a, so we'll do that. A, we'll need a store. You can make it global. We need a k. That's about it. Anything else I don't need. A, and sol 0, say start over id. Then you have your array like a. Then you have your array, not array, just 2D array, store, and you have your integer k. After this, what you need to do, if your id is greater than length, you don't need to do anything. Return 0, I think, in that case. Yeah, because it will be just 0. Otherwise, you have to choose any index which is greater than that. I is equal to id plus 1. Okay, can you just break about this point? 0 to 0 breaking, does it matter? Depends on the way how you are dealing things. So I think you can take, yeah, depends on the way how you are dealing this. I plus plus, and int r, not r, but r is basically previously defined. Int r is equal to just 1e9, because I need minimum. I'll initialize with not 1e9. Let's do int max, because yeah, after this I'll say r is equal to minimum of r comma. But now the thing comes, you are calling on which subarray? You're calling on id plus 1. This is the main part. Id plus 1, a passing, store passing, and then passing k. Now what will be the addition part? This would be the cost of, cost of making the subarray. Cost of, yeah, splitting this array about this point. If you are saying that, okay, I'm splitting at this index, that's what you are saying. You're calculating the splitting cost. Okay, you can do this in different variable, obviously, like split cost, and then yeah, is equal to, you know, okay, split cost is not this. This is the next cost you will be getting. And split cost is something like, if you're splitting from id to I, what will be the thing? The thing would be k, obviously, for sure, but the cost of this, which is stored in store of this, store starting from index, which index? id index, and going up till I index, because you are taking that also account, I think. Yeah, be calling on id plus 1. Yeah, and the next would be storing to say id plus 1. Yeah, and r would be equal to splitting cost plus next cost, and then you'll be saying return r. If it is -1, r cannot be 1e9. Okay, so yeah, that's fine, completely fine. Just do memorization for this recurrence. Repeating substrates are just basically 1D array, like id is just, changing. You can see id plus 1, we are going at every index. So let's say do it over here. If dp of id is not equal to -1, okay, sorry for that. If dp of id not equal to -1, you'll be going and return dp of id. Otherwise you'll be doing memset also, and then dp of id is equal to 0, and now over here mem set you can do at anywhere. It's better to do it in the first place. Mem set dp minus 1 size, oh yeah, size of dp, I think size of dp. Size of dp, something else. Now I don't think so. Let's try to sum this up. The all logic of this, and you can say a dot size. Whew. Something else? I don't think so. Okay, okay. That's the thing. SP cost, next cost. N is YR, N is not defined anytime. I think there is a issue over here. And the size NNIJ, n plus 1. ID of ID plus 1 greater than equal to N minus 1. What I'm missing? Runtime error basically was because one index might be going out of bound somewhere. First, let's check this without DP, okay, for sure. Return DP of ID will be DP minus 1. You can like keep it like that. ID greater than A dot size, V dot size, store. Okay. I think we are just wrong over here only. Like even if we just return 0, I don't care for that. Let's say if we return this 0, or even if we don't just call it, right, return 1. Let's say return 1. I think we are here wrong over here only, right? I don't think we are wrong over here, so let's keep it like that. Not return 0, return R, and return 1. Let's see, we'll get the, yeah, we are doing wrong over here while calculating this so-called store value. Map of A of the, okay, can it go out of bound? I don't think so, it should go out of bound. No. A dot size vector n plus 1 n plus 1 कुछ भी कर लो, n plus 1 n plus 2, but 0 to n m I to n I plus plus, yeah. For the I plus plus, you are doing I plus plus, how can you do that? Hmm. Let's not forget our dp. 14, wow. ID is greater than minus 1. I just strongly need to print the store array now. I'm very doubtful about this. Then I 0 0 answer for this is 2, answer this is 4, this is 5, this is 7, this is 5, man. Okay, this is 5, yeah. Okay, so n plus 1, they're saying don't do n plus 1, I think. But then what's the point? How is saying 6? Okay, you are starting from 2. Okay, 2, this is 4, this is nothing 4, this is 6. Yeah, I think it's correct, but why this is giving wrong then? I think store array is fine. I think yeah. Store array is fine. Then let's see ID plus one. I think we need to do ID plus one. Oh, you're calling on ID plus one. How the you have to call on I plus one? Yeah, because you're splitting at I index. Oh man. Whew. I don't know runtime overflow. What? ID plus one. Don't do ID plus one. Just do ID because yeah. Anything else? Submit. Let's see if something goes. TLEY. Am I not doing DP for you? ID is now not equal to minus one. You will return DP of ID. DP of ID is equal to DP of ID also. Then why? Greater than errors as return zero. I think you should do n ID plus one. But in this case, I think you'll miss out some cases. Yeah, ID plus one, so you just cannot do because you are going up till n also. So okay, that's fine. Equal to n, you are returning zero. Why this is not opening up? Okay, now let's move to the solution which we done here because that is the same thing which we done right in the contest as well as now. I think there is some network issue over here. That's why it's giving TLE. Okay, no, but yeah, the thing for this is why I'm treating this as ID because you can't split around that index also. Let's say you say I'm splitting around zero, so store of 000 is zero, but yeah, but then you go on ID plus one, that then you are adding just k for that, which is the value for if you take just this element like one index, one element. Are you getting what I'm saying? This index zero are you taking, and you are calculating answer for this one, which would be one. Select k all a dot size. Oh, okay. Why it is not referenced? It's huge issue. It's you should always use reference variables. RDI plus one. I have submitted the same code. I think just because of this I'm doing now. This is not good because n square time you're taking over here. Except what? Yeah, that was the main issue. Debugging, you cannot do debugging this. You must comment the debugging. Okay, guys, that's about it. Bye.